Going to explore a couple quick little things that won't be clear why we're doing it yet, but it will below. We're going to generate a formula for, hold on, need my pen, for sine. So we did cosine on Friday, and we're doing sine today. So we're going to generate that formula. It's not as difficult as the cosine one because we're going to use cosine to make the sine, but we have to figure something out before we can do that. So we don't have to go through the whole process like we did for cosine. It's easier. All the other ones we can base off what we already did. We're going to do that first, and then we're going to use it. But the using it is exactly like using cosine, except that the formula is slightly different. But you remember cosine, we were finding exact values of like pi by 12 or something like that. So that whole part is the same. If you weren't here, you got to get that figured out. So if you have questions at the end of that, I would definitely ask. But if you were here, that all looks the same. There's no difference. Okay, so first what we're going to do, we have to determine an equivalent expression for each of the following. We're going to need some of these. I don't think we need all of them, but we're going to need some of them. So let's figure it out. So determine an equivalent expression for cos of x minus pi by 2. Now there would be infinite of these, right? Because you could just add a period or add a period or add a period, but there's one in particular that we're interested in that's going to be the most simple. And so here I have the sine function. Oh, I'm only going to get, oh yeah, there we go. I want the whole thing. And I am going to, wait, what's our first one? I'm shifting it to the right, pi by 2. Okay, so here we go. I'm going to shift it to the right, pi by 2. And what function is that?
Sine.
Sine, right? If we're not just worried about that cycle, it looks like it's cosine that's been shifted, but if we look at the full function, then we can see that that is now sine. Okay, so I'm going to show that. I'm going to do a little sketch for myself, so you could do this too if you like in your notes, but it would go like this. Yep, and then up, and then like that, which if I extend it, I find is sine. Okay? And that's what we want. So cos of x minus pi by 2 is equal to sine x. The expressions are the same. The expressions are equivalent. It's an identity. Sine x is equal to cos of x minus pi by 2. And we also think about like, this isn't exactly what we're doing, but if I did the graph of each of these, it'd be the same graph. That's what we mean to have these equivalent expressions. And notice that this is a little bit different from the last one we were looking at, where it was cos of pi by 2 minus x was also equal to sine. So they actually both work, but this is not the same formula we were using, that co-function formula from before. Okay, what about this one? Cos of x plus pi by 2. So go back to our nifty little tool here, and we put cos back to where it usually is, and I'm going to shift it to the left by pi by 2. And what graph is that? Negative sine. Very good. Again, you could come up with other ones, but that's the one that we want. So this is equal to negative sine x. So we're developing these equivalent expressions because we're going to need them in a moment. Okay, so this one goes like this. And we can see that it is like negative sine x. Okay, and then what about sine? So now I want sine, and go back to the start. And the first one we're doing is sine of x minus pi by 2. So again, that's a shift to the right. So let's see what that looks like. What is that? Negative cos, very good. And the last one looks like cos. So we did an activity on this last week and we talked about it, and we've used some of these ideas a little bit throughout what we've done, and I hope that we're starting to feel a bit more comfortable with that. Like if we had been looking at that, if we have never seen that before, that might be kind of like, I'm not really sure I'm following, but I hope by now we can see that, because we're going to need these identities in a moment. So you got to believe them. If you don't believe them, I'll take my word for it. They're true. These are correct. So what does it mean to be equivalent? It means I could take one of the things and replace it with the other whenever I want, right? That's what it means to be equivalent. Just for kicks, we're also going to use the compound angle for cosine to simplify each of the following. So we showed these with graphs with transformations. We showed it visually that cos of x minus pi by 2 is equal to sine x. Can we show it algebraically? Apparently we can. So what is the formula for cosine of, in this case, it's a minus b, right? Good. So, and my a is x and my b is pi by 2. So it's going to be cos. So this is using the formula from Friday, right? Cos x cos pi by 2 plus sine x sine pi by 2. Now I can evaluate cos of pi by 2. What is it? Max? It's 0. Thank you very much. How do we get that? Probably from the graph is the easiest way to do it. This is the same as what we were doing in the last unit. Evaluating these things. This is one of the reasons why we like to be able to do it and we like to be good at it. Cos of pi by 2 is 0.
Sine pi by 2 is
yes. That's right. And if you're not convinced, again, we can go back to, there's cosine. Oh no, there's sine. So there's pi by 2. So sine of pi by 2 is 1, looking at this scale. And if I switch it to cos of pi by 2 is 0, right? So we're getting these from the graph. So this is cos x times 0 plus sine x times 1, which is what? 0 times anything is 0. Sine x times 1 is just sine x. So this is equal to sine x. So that was easy. We showed the same thing, cos of x minus pi by 2 equals sine x. Showed it a couple of different ways. If you want, you can try the next one. We're just going to do the same thing. This is a good little practice for remembering what these formulas are. What's the formula for this one, though? Minus, thank you. And then we're still talking about the same two values, cos of pi by 2 and sine of pi by 2. They haven't changed. So it's still 0. And it's still 1. And then 0 minus sine x is negative sine x. So again, sort of showed these a couple of different ways. Kind of cool. That is one of the benefits, in some ways, of these compound angle formulas, is that sometimes we can show proofs of these kinds of things, or figure out a simplified version of an expression using them sometimes. Okay? Any questions about that? All right, here we go. Now we're going to develop a formula for sine of a plus b. We don't know anything about sine of a plus b. What do we know about? No?
That cos a plus b is equal to...
We know something about cos of a plus b, right? Yeah, you don't have to say the whole thing. That's perfect. We know the formula for cos of a plus b. Can we use that? Like, can we change this into the cos one somehow? Anybody have an idea? Bang? Do you have an idea? No? Not yet. I love that. That is like positive thinking right there. I love it. Not yet, but it's coming. What if I help a little bit like this? Sine of x equals what? What did we just do? Equals cos of x? Okay, x minus pi over 2. Can I replace x with anything I want?
Yes.
So now what do I do? Max? Huh?
Replace it with pi over 2.
Kind of. What can we do? Is my x. So this is equal to cos of something minus pi by 2. What is that something? It's the a plus b. That's the x, right? A plus b. This is something that, like, it's simple when people point it out, but it's something we don't often look for, is remembering that I can replace a variable with an expression, like a plus b, even if it's a simple one. Now watch this trickery. Because can't I, like a plus b minus pi by 2, isn't that the same as a plus b minus pi by 2? Of course it is. I didn't do anything weird there. Do you think I did? You might be like, yeah, I don't know why. Like, of course it's the same. 1 plus 2 plus 3 is the same as 1 plus 2 plus 3, right? Same. Why would I want to do that? Well, if I think of this cos, what's so funny about this? M plus n, is it weird or what do you think? Yeah, okay. Cos of m plus n is our formula where I have an m and an n. If I think of a as my m and b minus pi by 2 as my n, those are my two things that I'm plugging into the formula. Can we do this? You try. See if you can write it out. So we're using the formula now. Some people are like, I have no idea what he's even asked me to do, but some people are writing, so that's good. Good try. No? Still a little confused, not willing to try? So this would be cos m cos n minus sine m. Sine n. Sine n, right? This would be this. Well, what's my m and my n? It's a and b minus. So cos a, cos what? There we go. B minus pi by 2 minus sine a sine b minus pi by 2. Yes?
So could you also do cos A plus B cos pi minus pi by 2 sine A plus B sine?
Could I have kept the a plus b as one term?
Yeah.
I could have. That may not have got me anywhere though. That might not have got me to where I want to be. And this will. Which again, you'll kind of have to take my word for it. Although we're almost done. Okay, now what do you see in here? Again, what can we, like, what are identities or what are equivalent expressions, that things we can replace with other things? Adam?
You can change like cos b minus pi by 2 into like back into sine x.
Cos of x minus pi by 2 is sine x. So cos of b minus pi by 2 is? Not sine x. Sine b, very good. Sine b minus, and what's sine of b minus pi by 2 from our four things above? Negative cos b. So sine a bracket negative cos B. And what do I do with my two negatives? Plus sine A cos B. I'm just going to mention that, like, this is the derivation that we're using for this formula, but it puts the two terms in a different order from how we typically memorize it, just so you know. And different people actually use it in a slightly different order, but this is how I usually do it. Sine A cos B plus cos A sine B. I just flipped them because you'll kind of see in a moment. Don't worry, because this is the form we usually use. That's all. Okay? And we could do the same thing. This is for the, remember, all of these are equal. So this is the formula for sine of A plus B. This is the one that we want. And I'll show you sine of A minus B. You could do the same thing like we did last time to figure that formula out. We're not going to do it right now. But that's that. Okay, so has everybody got that okay? I'm going to put these up here, and you can write down the other one. I'm going to give you a minute to do that. But there's the two that we did Friday, and the two, now there's your sine of A minus B. And so see how it's sine A cos B minus cos A sine B. See where the minus is? That's why we flip them around, because we usually write it in this order. I start the first one with sine and the second one with cos. But it's tricky, right? Because with cos, it's cos, sine, sine, and the signs flip. So if it's cos A minus B, you're adding. A plus B, you're subtracting. But sine, the signs don't flip. You get a negative and a positive and a positive, but it's sine cos, cos sine. So like they're similar, but they're different enough that it can kind of mess you up. But yeah. So we need to know all four. Remember I told you Friday, try your very hardest to have the cosine ones nailed. So when we add sine, you're just trying to keep them straight. That's kind of what you're learning. Any questions? And then what we do with it is exactly the same as what we did with cosine. So we do things like determine the exact value of each of the following. So here's two questions that we can do. Sine of pi by 12, and we're going to do sine of 11 pi by 12 as well. Isaac? Okay, hold on. For those of you who weren't here, I hope you watched the video, because if you didn't, you got to go back and watch it, because we did a lot of big stuff on Friday. But our trick for solving these pi by 12s, are for anybody who wasn't here, or for those of you who were here and just want to hear it again, do you guys have questions, or are you going to tell me what to do? Lucas, what do you think? Okay, well, wait for a minute, and I'll get your help in a second. We have three angles that are from the special triangles that we can find the exact value of. So they are pi by 6, pi by 4, and pi by 3. And what I want to do is I want to take them and turn them into pi by 12s. So this is 2 pi by 12. This one's 3 pi by 12. And this one's 4 pi by 12. And then I can also use multiples of those. Some of them are useful and some of them aren't. So I can use 8 pi by 12. I cannot use 12 pi by 12 because I can't use pi by 2 or pi or 3 pi by 2 or 2 pi. Those will not work. If you want to see why, ask me and I'll show you why after. Or try it for yourself and you can probably figure it out. So 12 is no good. 16 maybe. 6 doesn't work because 6 pi by 12 is pi by 2. But 9 is a really useful one. 15 possibly could be useful somewhere. Okay, that's a multiple of 3. And what about this one? This one probably 10 pi by 12, sorry. Could be useful. I could see that one being useful. The other ones I've already kind of hit, like 12 doesn't work. 14, I guess you could do 14 pi by 12. We don't see it as much. 2, 3, 4, 9, and 8 are almost all the ones we're going to need. But there may be another one here or there. So you just have, so if you weren't here before, you have to just kind of know these are the options to look for. And what I'm doing is I'm coming up with a sum or difference of any two of those that give me 1 pi by 12. That's the first step. That's the first thing we're trying to do. Everybody get that? So? Okay, go for it.
If there are two possible ways of doing this,
There are more than two. There are multiple. Yeah, you could. There's all different kinds. For sure.
so you can do pi by 4 minus pi by 6, or pi by 3 minus.
Yeah, or 16 pi by 12 minus 15 pi by 12. I don't know why I would do that because that's just going to complicate things, but you could. So, pick your favorite. There are two easier-ish ones, which would be like 3 pi by 12 minus 2 pi by 12. It's a little bit extra writing, but I would encourage you to write both steps for now until you really got it, but you need to at least write this step. So 3 pi by 12 is pi by 4, and 2 pi by 12 is pi by 6. So what I've done is I use this little gimmick of the pi by 12 chart over here to find the two that I want. And I've noticed that sine of pi by 4 minus pi by 6 is sine of pi by 12. Pi by 4 minus pi by 6 is pi by 12. Do it on your calculator. 1 over 4 minus 1 over 6. You'll get 1 over 12. Okay? And now this, and again, forgive me if I go kind of quickly here, but hopefully we're good at this, and this is not the part that we're reteaching. So we should be able to do this fairly quickly. Now here's where I use the formula. Sine A, cos B. And this one, the sign is the same, so it's minus cos A, sine B. Stop me unless we're good. Sine of pi by 4 is 1 over root 2. I saw some people earlier doing it on the calculator probably and getting root 2 over 2. But if you do that, your answers will not match the sheet, and they won't match the solutions, and they won't match like the way that I'm doing it because you got a different form. It'll be the same answer, and it would be acceptable. Try not to rely too much on your calculator for this, even if it, because here's a good chance for you to get a little bit better at this and a little bit faster at this. Remember what I said, a lot of people, here's where they memorize these, because you're doing 4 of them each time, and there's only like 6 of them, so you'd start memorizing them pretty quickly. And this works out to root 3 minus 1 over 2 root 2. Yes? Question?
Is it like always 2 root 2 anything?
For these ones, pretty much, yeah. Yep. Any questions? All right, I want you to try sine of 11 pi by 12. I could imagine somebody trying to use 10 pi by 12 and 1 pi by 12. Sometimes people try to do that. 1 pi by 12 is no good. We can't do that. I mean, we can, but look what we had to do to get sine of 1 pi by 12. Like, so 1 pi by 12 is not going to be useful in here, right? So be careful. You only want to use these ones. Don't add any others to it. Can somebody give me an example of what they used? Lucas?
I did 2 pi over 3 plus pi over 4.
So is that 8 pi by 12 plus 3 pi by 12?
Yeah.
How many people did that? 8 and 3. Who did something different? Max? 9 and 2 also adds to 11, so I'd be curious to make sure we get some. And I saw some people doing like 15 minus 4. That adds to 11. So you could do that too. Okay, so this is going to be sine of 8 pi by 12 plus 3 pi by 12, which is sine. And be careful, this is like, you got to reduce these properly. This is 2 pi by 3. Plus pi by 4, right? 2 pi by 3, not just pi by 3. You got to make sure you get that right. So sine A cos B plus cos A sine B. Sine of 2 pi by 3, this is where we need to use cast, so that's in the second quadrant. So it's the same as positive sine of 1 pi by 3, which is root 3 over 2. And cos pi by 4 is 1 over root 2. Cos of 2 pi by 3, cos is negative in the second quadrant. So this is going to be negative 1/2. And then 1 over root 2. And so this works out to root 3 minus 1 over 2 root 2. Any questions? Yeah?
So you only use the, like, you wouldn't actually multiply sine pi over 3 by 2 when you're putting 2 in the numerator?
What do you mean?
So
here?
Yeah. Like,
yeah, you know.
It's like double what that is, but it shouldn't be.
No.
Okay.
No. Yep.
So it doesn't really matter then if after like 3 pi by 12 or 8 pi by 12 in front, like the order doesn't matter.
Right, order won't matter. Absolutely. Did you do it a different way?
Well, no, I still solved it, but like I just added swap. So
Yeah.
On a test, I don't know if you.
No. You might get negative 1 plus root 3 instead of root 3 minus 1, but I don't care about that. I can figure that out, or, I mean, yeah. Isaac?
I'm not sure why I don't.
You got a different answer? I'll come and take a look at it. Yeah, that's curious. What did you use, 9 and 2?
Yeah, I got 1 minus root 2.
Cast? Recheck your cast,
Yeah.
because that can happen. Anybody else? All right, we got a worksheet for you to practice some more. That's it.